Hello, this is Mrs. Scarpel with topic 2.14, which is logarithmic data modeling. This is going to be using the regression models for logarithms or for logarithmic models. So for a given set of data, if the input values appear to change proportionally over equal length output intervals, then a logarithmic model is proportional, or is appropriate, excuse me. A logarithmic function model has the form y equals a plus b times the natural log of x, or y equals a plus b log x, where a and b are constants and b cannot equal 0. So you'll see here for example 1, we're just given two sets of points. When we have just two sets of points, we could find the regression or the equation by hand using a system of equations, or we could use our calculators. This is telling us to write two equations that can be used to find the values for the constants a and b. So we're going to do this by using a system. So and they tell us that we're using this L of x equals a plus b natural log of x. So for x, we've got 2. L of x, we have 3. So my first equation is going to be 3. I'm going to quickly increase the size of my document here, write this a little bit better. Here we go. So again, we have L of x is 3, so we're going to have 3 equals a plus b, those are the values we need to find, times the natural log of 2. Then for the other point, we're going to have 7 equals a plus b natural log of 5. Now in class, I believe I said something about you can isolate an a and substitute into the other equation. Another way to do this is to use the elimination method. So I have this system of equations, and I have 1a and 1a. I'm going to subtract everything from the first equation from the second equation. So 7 minus 3 is 4. Negative a plus a is going to be 0, so we won't have that anymore. And then we're going to have b natural log of 5 minus b natural log of 2. Since both of these terms have a b on them, I can factor out the b. So we're going to have 4 equals b times the natural log, let's write that a little bit better, natural log of 5 minus natural log of 2. We can condense this into one logarithm. 4 equals b times the natural log of 5 over 2, or 2.5. And then if we want to just isolate and get b, I would divide both sides by the natural log of 2.5. So b is going to be 4 divided by the natural log of 2.5. So I have my b value. For my values of a and b, let's see, we have the b, so now we need to find the value of a, and I'll have to use b to do that. So I'm going to go ahead and use our original equation and write 3 equals a plus b times, we know b now. We know that b is 4 divided by the natural log of 2. 4 divided by the natural log of 2.5. Times the natural log of 2. So now, to find A, we just need to subtract from the 3 minus 4 divided by the natural log of 2.5 times the natural log of 2. That's going to be my A value. I can write my linear regression as L of x equals 3 minus 4 divided by the natural log of 2.5 times the natural log of 2, so that's the A value, plus B is the 4 divided by the natural log of 2.5 times the natural log of x. Now that doesn't look very nice and neat, but that would be what the exact answer would be. If you're looking for an approximation, then we just need to enter some things in the calculator. So L of x would equal, let me pull up my calculator here, move it over so I can see what I'm entering. We're going to have 3 subtract 4 divided by, and I'm going to enter that natural log of 2.5 in parentheses, and actually I'm going to put that whole subtraction in parentheses because I'm taking that times the natural log of 2. And I get approximately negative 0. Let me pull up that calculator again. 0.025. If you round it, it's 0.026. Plus, now we just take 4 and divide it by the natural log of 2.5. And we have 4.365. So 4.365 times the natural log of x. So that would be with the approximate values. The equation written above is with the exact values. I'm now going to go through example 2. This time we're given a table, and when you're given a table, you can go ahead and use the capabilities of a graphing calculator, whether it's a TI graphing calculator, a Casio graphing calculator, or using Desmos, whatever graphing calculator that you have available to you. I'm going to go ahead and use the Desmos graphing calculator just because on the AP exam you'll have access to Desmos built into the exam, and I want to point out that when you're finding these logarithmic regressions, you need to select log mode. So what we have here are the sizes, and that's members, the number of members of a number of churches, and then below we have the average salary of pastors at churches of those size. I have already entered the table in my Desmos. If I want to do a zoom fit for my data, there's this magnifying glass. If I do a zoom fit, it'll get my graph in here nice so I can see everything. Now, to get the linear regression, we have these points separated by a line. I shouldn't have said linear regression. To get our regression, we're going to select that. It defaults to linear regression. So I'm going to change it to a logarithmic regression, and we'll see that it's set to do it as a natural log. And now you can also see that regression with our point. So it starts out fitting it pretty well, but out here I see him a little bit further away. So maybe as time goes on, it's not as good a model, but definitely to start with, it is a very good model. But I also should select log mode and see if that adjusts our curve any. So I've selected log mode and I didn't see a change, or yeah, I did. I think that is slightly different there. If I turn off log mode, well, I guess I'm not seeing a change. But our equation, we have a logarithmic regression. We're putting it in log mode, and we have our equation. Now, for working with the equation, for solving for things later, I can click this box that right next to equation, and it's going to put that equation into another box. And for purposes of part B, I'm going to change y to f of x. And you'll see why here in a minute. So I'm going to leave it as f of x equals. And I'm just going to take the time to jot this equation down. I want to make sure, yeah, logarithmic, log mode. Didn't change anything, did it? Well, we'll go with this for now. So we've got negative 90 or negative 90.349. I'm just writing these numbers down. Plus 29.739, which would actually round to 740. And then it would be natural log. So when I go back to my notes here, I can write my function as s of p equals negative 90.349 plus 29.740 natural log of p. So now, using that model, what is the predicted salary? That's the output in thousands of dollars for a pastor whose church size is 500 people. So remember in Desmos how I renamed this to f of x? If I want to find it for an input of 500, I can just type f of 500. And it gives me approximately $94,472. So that was 94,472. So the predicted salary would be $94,472 is the predicted annual salary. For a pastor whose church size is 500. So that's how you would use Desmos to find a logarithmic regression. And this concludes the video for topic 2.14.